Hello y'all, I will be showing you a game that I used to play when I was a kid. We would fill up several water balloons with water, and we would tie the balloon up. We would line up several small toy cars and try to race each other by pushing them to the finish line using the water flowing out of the balloon's opening. However, some balloons would have water flowing out at a higher velocity than others, and it all depended on the shape of the openings. Let's take a look. As we can see in the video, the car gets pushed by the outflow force of the water. Now, let's do a mathematical breakdown in order to see the car is being pushed with a different force when the balloon has a circle opening versus a square opening. Find the force of the outflowing water pushing the car. We need to first find the velocity of the outflowing water. Let's name this V2. We must use the Bernoulli equation in its head form because we are dealing with water. Our z components will be equal to 0 because there is no change in height because the balloon is in equilibrium with its surroundings, it being air. The pressure inside will be 1 atmosphere, which is equal to 101.33 kilopascals. Our P2 will be 0 kilopascals. Our V1 will be 0 because there is no inflow of water into the balloon. We also know that density of water at room temperature is 998.2 kilograms per meter cubed. If we simplify the terms, we get the following equation for V2. Plugging in the values for P1 and density, we get our V2 outflow velocity to be 14.25 meters per second. Now that we have our V2 velocity, we can use the momentum equation to figure out the force equation. Let's go ahead and derive it. If we draw a force diagram, the force present in the system would be the force of the water outflowing through the opening. If we draw a momentum diagram, we see that there is no inflow because the balloon is closed, therefore we only have the outflow direction. This gives us the equation force is equal to mass flow rate times velocity V2. We know that mass flow rate expands to density times area of opening times velocity. This is where we differentiate the area. As stated before, we will see the difference in outflow force between a square and a circular opening. Let's start with the circular opening. As we see in the video, the diameter of the circle is 1 inch. When we convert to meters, it becomes 0.0254 meters. Plugging that into the area equation, we get 0.0005 m squared. When we insert this area into the force equation we derived, we get a force of 101.33 newtons. Now let's start with the square opening. As we see in the video, the square is 1 inch wide. That converts to 0.0254 meters. Plugging that into the area equation of a square, we get 0.00065 meters squared. Putting this value into the force equation, we get a force of 132 newtons. This proves that the square opening has a greater outflow force when the balloon pops, and hence why the toy car got pushed further. Thank you for sticking around, and I hope y'all were able to enjoy this video.